One of the mysteries of spaceflight involves understanding the concept of an orbit and how it works. Like the theory of rocket engines, most people never really grasp how and why orbital mechanics work, but it's pretty easy. All you have to remember is that orbits all involve bodies in free fall. If you want to be a little more specific, orbital mechanics use Newton's first law, which says an object in motion will tend to stay in motion until acted upon by an external force. That's it. Take a look at this slide and let's see if we can explain it without using any math. If you climb up on a mountain and throw a ball or fire a gun parallel to the ground, the projectile will go out a ways and fall back to Earth. If you have a really strong arm or a large gun or you go much higher on a mountain, the projectile goes much further, traveling out of sight before it comes back to Earth. Finally, if you go high enough and impart enough energy to the projectile, it will travel fast enough and go far enough that it will simply continue to fall around the Earth forever, never coming back to ground level. This is assuming no air friction. Remember, we're in the true vacuum of space, so nothing slows us down. However, if we slow down for any reason, we begin to fall closer and closer to Earth until the atmosphere gets thick enough to really slow us down, and we come out of orbit and fall back to Earth. Now, how is all that explained in Newton's first law? In our example, the object in motion is the projectile. The external force is a combination of gravity, the force pulling the projectile down towards the ground, and friction, the force imparted by the atmosphere as an object moves through it. If an object starts with enough energy to overcome both of those forces, it not only goes into orbit, it leaves the orbit of the Earth and goes to other bodies in the universe, such as the Moon or Mars. But that's a story for another day. Orbital dynamics explains why there are rules for when we can launch windows, how much fuel is needed, energy budgets, and some of the rocket science that determines how high we need to go, where we should point, and how much energy to put in the rocket fuel. If you're designing systems to manage orbital dynamics, it's pretty high-level math, but it's all built on Newton's first law. And remember, orbits are just free falls. For our purposes, it's enough to understand the basics and a little of the language. The high point in any orbit is called the apogee. I remember A for altitude. The low point is called the perigee, and I remember P for planet. The rest of orbital mechanics we'll leave to the engineers.